Alright, happy Sunday, guys. I think today I'm gonna go over AP because normally it's like I do SL, IB, then an HL IB, and then an AP BC Calc. But before we get started, I wanted to talk about last time. Man, those last two questions, they took me a while. Well, actually, not the last one, but the second last one. And I went to sleep kind of bitter. And then I thought about it, and I realized why I don't like it. Like, this was the last question, but the second last question, this one, where it took me so long because I didn't realize the roots could be complex, that's because this question is hella misleading. And I know, okay, yeah, you know, you're in higher level, you should know that roots could be complex, but like, come on. The way that you set up the question, you use the variable x instead of z, and then, you know, you state that you have roots, but you don't even say what type of roots they are. Like, this totally sets it up to be real roots. So you know what? Yeah, okay, I struggled, but I think that question was a little unfair. But whatever. Enough about IB. We're gonna go through 2017 BC AP Calc free response. And then I've done two so far, so I kind of know the pattern. The first couple of questions are going to be calculator, and then some will be non-calc. And then there's kind of like a pattern, and I want to see if that's true. Like, the first question for the last two papers were about like rates. I mean, I guess all of calculus is rates, but like the first one was about some escalator thing, and then I forgot what the second one is. But let's see. So we have a tank that's 10 feet tall, and then you got the area of the horizontal cross section. So then it's given by some function, and then A is continuous and it decreases, and then select the selected the selected values for certain heights are above. Okay, sure, whatever. Okay, use a left Riemann sum with 3 subintervals indicated by the table to approximate the volume of the tank. Indicate the units of measure. Okay, so basically we have 3 intervals from 0 to 2, 2 to 5, and 5 to 10. So those are our Riemann intervals that we're going to use for our Riemann sum. Well, just intervals for our Riemann sum. And we want to use the left Riemann sum. So we will be using the leftmost point for each one. So first, let's find out what the lengths of the intervals are. So the first interval, which is from 0 to 2, well, I guess it's there for you, it's 2. And then 2 to 5 is 3, and then 5 to 10 is 5. And then we'll be using the leftmost values for each interval. So here's the first intervals, the second intervals, and then the third intervals. So my volume is approximately 50.3, which is the leftmost point of the first interval, times 2 plus 14.4 times 3 plus 6.3 times 5. And these are calculator questions, so we can just put this all in a calculator. So 50.3 times 2 plus 14.4 times 3 plus 6.3 times 5. So 175.3. And I won't deal with the units today. Okay, does the approximation in A overestimate or underestimate the volume? This is an overestimation. And then you have to explain. And then that's because you're using a left Riemann with a decreasing function. So visually, right, if your function is decreasing, and then you split it up into however many intervals you want, let's say, like in this example, we do 3, you're using the left Riemann sum, which means that you're using the left point of the function, or well, you're using the left boundary of the interval to decide how tall your rectangle is going to be for your Riemann. So you see there's extra area in our rectangles, so this is compared to the actual area below the graph, so it's an overestimate. Okay, and then let's see. The area of the horizontal cross section is given here. So now we know the function of the area. Based on this model, find the volume of the tank. Okay. So now that we actually know the function, then the volume of the tank is the integral from 0 to, I guess, 10. Of this function. And then this is just calculator work, right? So I'm just gonna open up Desmos. So I want to integrate from 0 to 10, and then my function is 50.3 divided by e to the power of 0.2 x, let's say, plus x. Integrand must end with a, yeah, okay, dx. So 101 point, I don't know how many decimals we want. Does it say? And it doesn't matter. Okay, so 101.33. And then indicate units. I'm not going to do that today. So that looks good. And then we're done this question. And then number 2. Okay, we have a grocery store opening. There's 50 pounds of bananas, and then people remove bananas at a rate here. So here's your rate. And then this one I think is going to be like the escalator one. So this is bananas leaving, and then blah, 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 blah. And then after the store has been open for 3 hours, store employees add bananas. So you see here's a rate of bananas. So I guess the bananas going in, bananas going out. Okay, so how many pounds of bananas are removed from the table during the first 2 hours the store is open? So we just integrate from 0 to 2 of the rate going out. So back to my calculator. And I'm just gonna change this a little bit. So I'm just typing in the function. And I get 20, as long as I type this in properly, which I'm pretty sure I did. Okay. And then let's see, find the derivative of f at 7. Using correct units, explain the meaning of the context. So again, this is just calculator work. I need to take the derivative of this function that I already typed in. So let me call this f. And then I can just calculate f of 7, which is negative 8.12. Okay, so this is the rate of change of our rate of bananas leaving. So after 7 hours, the number of bananas that are leaving, like the rate at which the bananas are leaving, is decreasing by 8. So you would say that as your like context. And then let's see, the number of pounds of banana on the display table increasing or decreasing at t equals 5. Okay, so what we need to do is we need to take the bananas going in, take away the bananas going out, and then we want to find out if this is increasing or decreasing. So I don't even know if this is proper notation, but take the derivative of this, add a t-value of 5. Okay, and then that's easy enough to do. So let me just type in g first. So 3 plus 2.4 natural log t squared plus 2t. Okay. And then I take g prime at 5, and then I subtract f prime at 5. And I get negative 0.88. So because this is negative, then it's the amount of bananas want to find out if the pounds of bananas is increasing or decreasing. So I don't think I need to actually find the derivative. I just take the bananas going in minus the bananas going out. So maybe that's easier. Let's get rid of this. Negative 2.2. Either way, it's negative. So then we can say that it's decreasing. Okay. And then how many bananas are on display at the time t8? Okay, so let's find the change in bananas, which is the integral from 0 to 8 of the bananas going in, take away the rate of bananas going out. And then this is just the amount of bananas that have changed since the beginning. And then you also need to add to this the amount of bananas in the beginning. And it's right here, there's 50, so plus 50. And then just take the derivative of this stuff, or integral. So again, calculator. So integral from 0 to 8 of g of t minus f at t dt. And then add 50. So apparently there's 41.8 pounds after 8 hours. Okay, and I think there's only 2, right? Yeah, and then now we go on to the better ones without a calculator. So here's number 3. Alright, so let's see. We have a graph of the derivative, and then the function f is differentiable from 6 to 5. And we know that f at negative 2 is 7. And then this is a semicircle. Okay, find the values of f of negative 6 and f of 5. So essentially, this is similar to a question in another paper we did, but we're going to use the fundamental theorem of calculus. And if I take the integral from negative 6 to negative 2, and the reason why I'm using negative 2 is because I know the value of f at negative 2. Okay. So according to the fundamental theorem of calculus, this is just a function at 2 minus a function at 6. And this is nice because we're trying to find out what this is. Okay. So that's what it equals by the fundamental theorem of calculus. We also have a graph, and then I know that the integral of whatever is just the area from negative 2 to 6. So from negative 6 to negative 2, which is just this area of this triangle, right? So this has a height of 2 and a base of 4. So I know that this is just the area of the triangle, which is 2 times 4 divided by 2, which is 4. Okay, and then this is nice because I know this is 7. So this means f at -6 is 3. And then we just repeat the process again for f of 5. So I guess I'll write it up here. So from -2 to 5, we set up one side of the equation by the fundamental theorem. And then we set this equal to the geometric interpretation. So that's the area from -2, which is this half circle, to 5, which is this triangle here. So this is a half circle, and it has a radius of 2. So then that's half of pi r squared. So this ends up being 2 pi. And then this is a triangle with a height of 2 and a base of 3. So the area of that triangle is, well, 3. I'll just write it like that. Okay, and then this area is above the x-axis, so it's positive. This area is below, so then that's 2 pi is negative. So in other words, this equation is 3 minus 2 pi. And again, we do our substitution. We know that this was 7. Let me just move that here. And then likewise, just a little bit more algebra. Andreas, thanks. So here is f of 5. Okay, my alert is it's been really quiet, so I'm gonna see if I can just up the sound on that. So that was what follows. Okay, hold on. That's really quiet still. Huh, this is as loud as it gets. Oh well. Hey Ma Vincent, hello. Hope you are having a nice weekend. Are you gonna give us a review package? Any work this week? Yes. We are gonna continue learning the next unit, and I'll also throw in a review package for you guys so that you can also study. But like I said, schedule's tight, so we gotta keep going. Okay, so where was I? I found out part A, and then let's see, what intervals is f increasing? Okay, well, f is increasing when your derivative is positive. So let's just look at that. That's right here and right here. So in other words, when t is less than -2, and also when it's in between 2 and 5, according to this graph. Okay, and then let's see, find the absolute minimum value on the closed interval. So the absolute minimum means we need to check all of the places where we have critical points. Well, actually, let's just do local mins. So we need to check the local mins and then the boundary. Okay. So our local minimums are where our derivative is 0. So it's 0 here and here, and also here, but this is a boundary point. And then to be a local minimum, we can do first derivative test. And then you know that a function is a minimum when it's positive followed by a negative. So the graph looks like it's increasing and then decreasing. So let's see. Oh wait, that's a maximum. Switch this. Okay, so according to our graph, so right here we have a minimum because the value of my derivative is negative here, and then it becomes 0, and then it becomes positive. So by first derivative test, we have a local minimum at 2. So we're going to compare the three values. The two boundary points. Can I change my color? Okay. So f at -6, which we found out in part A, which is 3. The other boundary point, which is 5, which is 10 minus 2 pi, and then our local minimum, which is f at 2. Now the only issue is we don't know what this is, so we kind of need to repeat what we did for part A to find it. So I know that f of 2 minus f of 2 is from here to here. So again, I'm just repeating what I did in part A. And then from -2 to 2 is this, well, it's the half circle, which I found out earlier is -2 pi. And then, again, I know that this thing is 7. Okay, so here are the three possibilities. We have 3, 10 minus 2 pi, and then 7 minus 2 pi. So 2 pi is more or less 6. So the smallest one is this one, because 7 minus 2 pi is a little under 1. So here you go. This is my minimum. The absolute minimum. Okay. And then for each of the second derivatives, find the value or explain why it doesn't exist. So this is going to be the tangent slope of the derivative graph. So at f of 5, negative 5, that's right here. And this slope is pretty straightforward because it goes down to 2 spaces and then to the right 4 spaces. So the second derivative of negative 5 is negative 2 over 4, which is negative 1/2. And then next up is we need to find, oops, not triple, double. No Discord just yet. We're slowly setting it up. Yeah, I don't know why it's so quiet today. How are you, RGPT? Okay, so then let's find the tangent slope at 3. But we run into an issue, you see? First day I took a break for a month. Holy, that must have felt good. Unfortunately, you see here on the graph, at 3 we have a cusp. I didn't want to erase all of this work, so let me just draw it over here. We have a cusp, so the derivative doesn't exist there. Didn't know what to do? I don't know, just relax. Did you play games? Watch TV? Go exercise? Go out to eat? Okay, so the second derivative doesn't exist at 3. And then we have to explain it. And the reason why it doesn't exist is because the limit as t approaches 3 from the left of the... Actually, hold on. Let me write it using first principles. Just some games? That sounds like a good time. Okay, so what we're going to do is we are going to find the tangent slopes on both the left and right side of 3, and then they're not going to be the same, which means that it doesn't exist. But yeah, quiet chat today. I don't know what's going on. I've also been doing my own personal homework for my master's course most of today, and it's just calculus, so I'm in a pretty good calculus mood. My sound is quiet, like my voice or the music? Voice sound? This is as loud as it goes. Is this too loud? Because it's like saying my sound is going into the yellow. Way louder? Oh well. I'll trust that you guys can adjust your own volume too. Sure. How's the background music? There is background music. Quiet enough? And loud enough? Yeah. Yeah, math streamer. There's only a couple up here on Twitch. Kind of dope, I guess. You got math questions? Or are you just here to listen to me talk about some random math? Okay, I really didn't want to erase this, but it's getting way too messy. Actually, I don't need to. I'm just gonna zoom in a lot. I got a question, but I'm too dumb to explain it. What do you mean by you're too dumb to explain it? You can try asking it in the best way possible, and me and also RGPT, who's also good at math, can see what we're trying to work with. Let's see, and then while RGPT asked the question on Stack Exchange, and then they gave you a bad response, yeah, it's hit or miss on Stack Exchange. Okay, meanwhile, so you see the tangent slope as you approach from the left side is a different slope than on the right side. On the left side, it has a slope of 2/1, and then on the right side, it has a slope of -1. So if we just write that out, these two things are not equal, so our limit doesn't exist, so our whole derivative doesn't exist. Okay, so yeah, integral partielle, I'm assuming means integration by parts. So do you have an actual question that goes along with it?
Shall we take a stroll?
If they didn't give you one, then it's okay. You don't need to think of one. I can just come up with one. Yeah. So RGBT is kind of guiding you through, and then let me just walk you through it, or walk you through RGBT's advice. So let's say that you have two functions, right? And they're being multiplied together. If you want to take their derivative, then we know that this is a product rule. Or actually, let's use a Leibniz notation. So this is just, you know, product rule. And then essentially there's an integral version, which is what integration by parts is. You're trying to undo basically some sort of product rule that has happened. So for example, Arab, thanks. So for example, let's say that you want to integrate, I don't know, something like this. Actually, let's use sine. It doesn't really matter, but... Now, there's not really a clear way to do this as it stands. So, what we basically do is we try to use this. And here's what I mean. First, you're going to set one of these parts to be... Actually, man, I should think about this a little bit better. Because normally integration by parts uses u and v, so let me just use u and v. So what we do is we choose one of these things to be u, and then the other thing to be, for example, the dv part. And it's up to you which one you get to choose, and that's where the problem comes in of you practicing. And essentially what we do is we are saying that this integral is this part. So we can just do a little bit of algebraic manipulation and say that instead of trying to figure this out, I know that that is equal to rearranging the formula. Oh gosh, let me just move this a little bit out of the way here. Okay, so instead of actually trying to find the integral, instead we know that it's equal to this, and maybe this right side is easier to work with. So you get what's wrong? Maybe. Yeah. Starting from basics is good. And then of course, once you set something to equal to u and something equal to dv, then you also need to find du, which I guess in this case is just 1 dx. And then, I knew it. I should have used cosine. So yeah, once you set this up, then you just derive this u part, and then you integrate this part. And then you go from there. Then you can just plug them both into here, right? You know u and v, because you said that it was this one and this one. And then you know this one. Of course, we're also doing the integral, so when you integrate this, you're integrating each term, and then because you're taking an integral and then a derivative, these kind of cancel out. So we find this by changing it into this form. 3rd grade only, freshman college. Yeah. But yeah, that's a, integration by parts. Indonesia. Sweet. I need to go to Indonesia soon. Well, not soon, but sometime in the future. I want to eat all of the food there. Man, I'm moving at a pretty good pace. At this rate, I might just finish this paper early. Because... okay, I have 3 questions. Who knows how long that'll take. Okay, next one. Yeah, no worries about it. I mean, that's why I do the stream. Jazz, no homework tonight? Oh, you should have been here on Thursday. She asked like 10 questions. But sort of, yeah. RGBT is like a master's graduate student in math, currently studying on his way to becoming a doctorate. He does teach a junior course, like a Math 100 course, that he likes to complain to me about. But he's actually probably better at math than I am. Well, not probably. He is better at math than I am. But I'm an actual teacher, high school teacher. So it's good. He fills in the blanks for me whenever he's here. Had to teach a 200 course? Oof. I mean, you already did not enjoy the 100 course. I can't even imagine. Yeah, he hates engineers because they're so dumb. Anyways, okay, let's see. At a time t0, sure, we have a boiled potato. The internal temperature is 91 at the start. And then it's always going to be greater than 27. Is that room temperature? 27? I guess. Alright, so let's see. The internal temperature can be modeled by this function. And then let's see, write an equation of the tangent line of the graph of h at time 0. And then we can use that to approximate it when time is t. (21) is room temperature? I have no idea what room temperature is. But for some reason this potato will always be at least 27. Oh. Anita Yellow has a question. Well, go ahead and ask it, Anita. In the chat, I guess? Oh boy. Let's see this. Let PT be the number of likes obtained by an influencer? Where did you get this question from? And if P of T changes at this rate, then how many more likes does the influencer obtain 3 pi over 2 years after joining Instagram.com compared with 0.2 or pi over 2 years after joining? Gosh, like, just give me the numbers. Why you gotta give me this lame context? And why does it have to be like, you know, they tried to make it relatable, but it just made it worse? Like, just talk about bananas or something, like the question I just did. Alright. Yeah, it's pretty cringe. So let's see. Let's write down some things. P of T is the likes. And then this is for some T years, okay? So this was on your quiz, so you already wrote your quiz. Well, actually it doesn't matter. If you're in the middle of writing your quiz, I'll just help you cheat. It's fine. You're not one of my students, so... And then PT changes at a rate. So you actually know what the rate is. So P prime of T. So this is 30 plus 10 cosine T. And then you want to find out how many more likes they got after 3 pi over 2 years. Compared with pi over 2 years. Is factoring out 10 an option? It is, but I don't know if it's necessary. So basically, what this is you need to find out the number of likes. So you're going to integrate this. And your starting point is the pi over 2 years, and then you're integrating this from pi over 2 to 3 pi over 2. So this will tell you the number of likes you got in between this year and this year, because this is the rate of change of your likes. You can factor out 10, it's fine. I just don't know if it does anything, really. Let's see. My major, not really having to do with math, but yeah. Yeah, brain exercise, it's good. So, are you unsure of what to do from here? Are you okay with how this represents the amount of likes you'll get? Anita Yellow? Because from here you're just evaluating this integral, which is pretty straightforward. Do you get where this integral comes from and why this represents your answer? Because this is the hard part. Once you get to here, like making this equation yourself, then the rest is pretty straightforward. Unless you're having difficulties actually doing the integration. Because from here you can just split up the integration. You can split it up into the two terms. You factored out 10? Yeah, it's fine. Actually, you know what, here, I'll show you how you can do it with half, even if you factor out 10. So if you want to factor out 10, it's totally fine. Then you actually... Oh no, 10 times 10 is 20. Well, hopefully your prof isn't like super mean about that. But yeah, so if you factor out a 10, that's totally fine. All that does is that this coefficient of 10 no longer affects the actual integral, so we can write it out in front. And then I guess it makes your integral slightly easier because you have smaller numbers now, but you're still doing the same thing. Yeah. See you later, Andreas. Thanks for stopping by. Anyways, once you're here, if you wanted to factor out that 10, then it's fine. You just need to remember to multiply everything by 10 at the end. So if you want to integrate 3, then it just becomes 3t. And of course you use fundamental theorem of calculus, and then you plug in the upper bound, and then you subtract it from plugging in the lower bound. And then the integral of cosine is sine, right? And then all of this is just pretty straightforward calculator work, I think. Time to plug her in. So we got 10 outside, and then we have 3 times 3 pi over 2, which is 9 pi over 2. And then you subtract 3 times pi over 2, which is 3 pi over 2. And then, let's see, sine of 3 pi over 2. What is this, -1? I can't think of angles right now. And then we subtract from that sine of pi over 2, which I think is also just 1. And then from here, there's just more just crunching through the numbers. So 9 pi's over 2, subtract 3 pi's over 2 is 6 pi over 2, but 6 divided by 2 is 3, so this is 3 pi. And then we're adding, well, negative 2, so minus 2. So 30 pi minus 20, I guess. So this is how many likes your Instagram influencer has gotten in between pi over 2 years and 3 pi over 2 years. So stupid. What a stupid question. So hopefully that makes sense. I'm not entirely sure where you got confused on, but hopefully this cleared up your confusion. Yeah, it makes sense. Oh, I guess you need the units, which are hearts on Instagram. You factored wrong? Oh, that sucks. But like I said, hopefully your prof isn't gonna mark you too bad on the stupid mistakes. Okay, so hopefully you don't lose too much work, because all you did is, you know, that should have just been a 3 plus cosine t, so it's fine. At least I would say it's fine. I wouldn't take off too many marks. But then again, I'm not a professor. I'm just a high school teacher. A lot of students in engineering put random units, yeah. Because, like, you know how they get by in physics, right? They just, like, do unit analysis. And then they just multiply and divide the right units if they don't know what the formula is, because they know what the units in the answer should be. Anyways, back to this one. I need to find the tangent line at h equals 0, so easy enough. I need to first find the derivative of h at 0. So what is this? Yeah, but there's no units in any of their work. They just compute something and then a random unit pops up. I don't know. They're, like I said, I don't know how many times I gotta say this. They're just dumb. It's really cool. Yeah, so cool. Just wait until you get someone that gives you like Instagram likes as their units. Okay, so I need to find the derivative at 0. So I plug in 0, and then h is a function of t, so I'm plugging in h of 0. Yeah, 4 hearts. Or if it's on Facebook, they draw a little like thumbs up. Spend like 2 minutes trying to make a realistic hand. Social units. That's in China. Social credit. You've gained 2 credits for ratting out your neighbor. Okay, h of 0 is 91, so I know that that's 91. So what is this? Negative 1/4 times 91 minus 27, and then this is without a calculator. What the heck is this? 64? And then 64 divided by 4 is 10 plus 6, 16? Negative 16? Sure. Okay. So then your equation of your tangent line at t, I guess, is y is equal to negative 16t plus 91. So this is in slope-intercept form, and I know the intercept because it's at t0. So t0 is 91. So there you go. Oh, and then we need to estimate the time at time 3. So then I plug in 3 into here. Why are they making you do this calculation without a calculator? So 16 times 3 is what, 48? And then 91 minus 48 is 43? So this potato is 43 degrees after 3 minutes? Sure, let's just go with that. Okay, then we use the second derivative to determine if part A is an underestimate or an overestimate at time 3. Okay, so let's find the second derivative of this. So the second derivative is negative 1 over 4 multiplied by the first derivative according to chain rule, right? Yeah, so if you took the derivative of this, then you just get the negative 1 over 4, and then you need to chain rule with the function of h. And then at time 3, I know this is just 1 over 4 times 43, which is negative. So in terms of your approximations, you have a negative. So this is concave up or down. So if your actual function is like this, and then you're like concave down, then you're an overestimate, right? Something like that? I don't know. It's been a while since I've thought about under and overestimating. But it's a 50-50 chance. Okay, and then if it's less than 10 minutes, then we have a different model here. And then of course it's still 91 degrees at the beginning. Then we need to find g of t. So I need to integrate this. But before I do, because g is a function of t, we're going to do a separation of variables. So if I move everything related to g onto one side, then what do I get? I guess something like this, right? Or is this negative? I think this is negative 2 over 3. Okay, so we separate and then we can integrate. So on one side, we just get t, and then on the other side here, you get g minus 27, and then what is this, 1/3? And then over here, -3? Something like this. Plus a constant. Let me just double check. Take the derivative of this, the 3's cancel out, you get the negative, you subtract 1, yeah, and then chain rule, there's just the 1, so this works out. Okay, and then we need to find the constant, so that's why they tell us this condition, g of 0 is 91. So that means that g, which is 91, and then this happens at time 0, and we can find our constant. So this was 64, right? And the cube root of 64 is 4? So C is -12. And we need to find an expression for G, so now that I know C was subtract 12, I can just isolate for G, right? So G of T is going to be T minus 12 divided by -3 to the power 3 plus 27. Okay, and then based on this model, what is the internal temperature at time t? So now I just plug in 3, right? Okay. So 3 minus 12 is -9. -9 divided by -3 is -3. So -3 cubed is 27. So it's 27 plus 27. So 54 degrees. Let's see how close this was with our estimate using the first thing. 43 degrees. Pretty big difference. Oh well, okay. Second last question? Yeah. Oh boy. Okay. We have particles moving, so... Oh, did I write? Oops, this should be 3. Did I say -3 though, or did I say 3? That's the important part. Oh, my bad. Yeah, I'm glad you didn't see Thursday though. Thursday was really bad. I was so tired, and then I struggled on a question that I really shouldn't have struggled on. Took way too long on it. But to be fair, I ranted at the beginning of this stream And I said that it was a little misleading. Here, actually, I'm gonna rant again because you know what? Feels good to rant. So here's this question, right? You have a cubic and then it has roots x1, x2, x3. And then basically, if you know like b is -9 and c is 45, and you know that the roots follow an arithmetic sequence, you can find out one of the roots is 3. And then from there you can find out the constant in the cubic. So you're using like the Vieta formulas, but I got stuck really hard. And the reason it turns out I got stuck is because you need to realize that the roots are complex. And there's like, yeah, okay, to be fair, the curriculum says at this level you should expect complex roots, but it's so misleading. They use x's, they tell you that there's roots, but they don't even tell you what kind of roots they are. I got baited. I think that was a little unfair. All right, what is this? 2 particles, right? Particle P. You know what's common in high school? Yeah, well, it's not about how common it is. It's just, you know, why not write the cubic polynomial in terms of z? Or, you know, actually tell me, or tell the person taking it that your roots are, you know, complex. Anyways, okay, this is position of particle P, and then this one is velocity of particle Q, and then we know Q is at 5 when the time is 0. Okay, so for 0 to 8 seconds, when is particle P moving left? So particle P is moving left when the derivative of the position is negative. Okay, so if I take the derivative of that right here, requires a little bit of chain rule, but on top I have 2t minus 2, and then on the bottom I have just the quadratic. Okay. And then to find out where this is negative, well, it's a division, so I should find out where things are positive and negative for the numerator and denominator. So
I saved some shit for you over here. Oh wait, I have more shit.
So let's see where this numerator is positive. Well, that's easy enough to find out.
Wait, I have to get the shit. I have more shit that I said.
It will be positive for times greater than 1. So we have that. And then over here, let's find out where.
Yeah.
Let's find out where this is positive. So
Can you hear me?
it's not factorable. So do you have to use quadratic formula? Hold on. I'm gonna complete this square.
I've been hearing the Lynn's like screaming right now, so he's just like talking on the side.
So I think
Right.
the square completes to here. So visually, you have the vertex of your parabola at 1 and 9, and then it opens upward, so it's always positive. Okay, so this is always positive. And again, we are interested in the derivative being negative, which means I need to find out when this is negative, and it's negative when t is less than 1. So when is the particle moving to the left? It's moving to the left in between 0 and 1 second. Okay. And then for times 0 to 8 again, when are the particles moving in the same direction? So first I need to find out when Q is moving left and right. So the velocity of Q is this.
I have one right here. I hit it. But you should have crafted it first and then brought it over. That way you can fit more in here.
Stream, give me functions that vanish at infinity.
No, it's iron.
Are you trying to get the chat to start talking? No one knows what you're talking about, RGBT. I don't think anyone's at that level. But anyways, okay, so this quadratic is factorable, so I don't even know who you're talking to right now, RGBT. Okay, so we can factor this. So I know when my velocity is 0.
Oh, that was the festival stall?
Just the stream in general. I feel like high school students know a lot of functions. They do, but this whole limit stuff, they don't see until grade 12 calculus.
Sell your shit.
And I have a feeling there's not a lot of those in the stream right now.
Where did all of your iron go?
Okay, let's find out which intervals. Well, I guess it depends where you're from. Where I'm from, then yeah, it's all happening in grade 12.
That's not a lot.
Okay, so let's do some test points.
That's like 10% of your network.
So if I plug in 1,
Wait, what do you wanna buy in the
then I have a negative times a negative, so this is positive.
Oh.
If I plug in 4,
I thought you wanted to buy
I have a negative times a positive,
but you didn't have enough
which is negative.
money in here worth buying.
And then 6 is 2 positives, so this is positive. Okay, so then this is Q. And then the question says I need to find out
Fast forwarding
when they're going in the same direction, so I need to compare this to P.
Well, I don't know, because then are you gonna come back with more iron frames?
And luckily we found out.
These are my reject ones that I was just gonna give away to people for free. I mean, you can take them, but I thought I already.
What was I going to say? Luckily, we know when P is moving left and right. That was part A. P is moving left in between 0 and 1. And then it's moving to the right everywhere else. So if you just compare where they have it in common, and they're moving in the same direction, they are both positive here,
Not. You can mine them if you want.
and they're both positive here. Yeah, if you're in IB, and depending on your teacher, you might learn a little bit of limits in grade 11. The extent of limits is very superficial though. If you're in the standard level course, it's slightly less superficial if you're in the higher level course. And it also depends on whether or not your teacher wants to teach you the calculus section in grade 11 or in grade 12. Yeah, I make my kids learn it in grade 11, and then we save statistics for grade 12. But, you know, it depends on the teacher. Because if you went in a linear fashion, the last unit in the curriculum is calculus. It's called Unit 5. Whereas Unit 4 is stats. So if you were to go from 1 to 5, then calc is actually last.
Like a couple bucks, I guess.
Okay, RGBT is gonna bug you a little bit, Anita. Meanwhile, let me finish this off. So, from between 1 to 3, and between 5 to 8. Oh, I guess these should be T.
He got a Wacom tablet. It's like a tablet with a pen that you just
Okay, and then let's see. Find the acceleration at time 2. Is the speed increasing, decreasing, or neither? Okay, so we take the derivative here. So that's going to be 2t, I think minus 8. Yeah. And then we want this at time 2. So 2 times 2 is 4. 4 minus 8 is negative 4. So we have a negative acceleration. Now, you have to be careful with physics applications, I guess. Because I know when you see a derivative and you see negative, it means you're decreasing on instinct. And the function is decreasing. V is decreasing at 2. But notice that they're talking about the speed of the particle. So it also depends on whether or not the particle is moving to the left or to the right. Because this is meaning it's accelerating towards the left. So if you're moving to the left at the same time as you're accelerating to the left, then you're actually getting faster. So at v, so the velocity of q at 2, we can just check our chart right here, is positive. So it's actually moving to the right, I think. So if I did this right, then that's positive, right? So you're moving to the right, but you're accelerating to the left. So you're actually getting slower. So this is decreasing. Can I make one up when he's done? I wasn't even paying attention to what he was asking. Anyways, let's see. Find the position of particle Q the first time it changes direction. So when it changes direction, that means that the velocity is 0. The first time that it does that is at 3 seconds.
Saturday, but that is on like Thursday, so.
To find the position of particle q, that means that I'm going to take the integral of the velocity. So I'm taking the integral from 0 to 3 of the velocity function, which is t squared minus 8t plus 15. So we have some integrals to take. From 0 to 3. This is pretty straightforward. Okay, fundamental theorem of calculus.
Okay, you can come back to what I lived on.
So this is 9, right? And then 3 squared is 9 times 4 is 36. And then the 15s cancel. So the position of particle Q is negative 27. So like 27 whatever units to the left of where it started.
Try to keep track of like the last day that I played, which is usually Sunday, and then whatever, because I don't.
Nice.
Stop 5% on Sunday.
And I think that's it.
And then days go forward, so then when I do.
Man, I'm making good time.
days up to
Today's a chill chat.
and then I go back.
Because I think this is the last one, right? Yeah.
Because sometimes I do.
I don't know.
Forward to
Should I just play
Sunday, and then I get lazy.
some more Baba's You after? Okay, let's see what this is. F is a function here. G is differentiable, and we have a table here. And then we have H as a graph. What the hell? Okay. 3 different ways to represent a function. F, G, and H. Anyways, okay, so what does it say? Find the slope of the tangent of f at pi. So we can just take the derivative of this, which is right here. So I think that's the derivative, and then I plug in pi.
So Dokun went back down. I'm so sad. I'm so sad for you guys.
Okay,
Me too.
let's see. This one is 0. Cosine pi is -1. Sine of pi is 1. So all of this is just negative e.
Yeah.
Okay, sure. All right, then let k be the function defined as h of f. Then we need to find k.
Doing that is less stressful than the turnips.
K prime of pi.
Okay, but
Okay.
these are turnips. You can't time travel until you sell it. Because if you time travel and you fuck up, well, if you time travel and then you fuck up,
Which
then
one is it?
you lose
Okay,
all
H into
the
F. Okay, so if I wanted to take the derivative of K, then this is going to be a chain rule. And now I can evaluate this, I guess. And I found out what that is, but I need to find out what this is. So let's see. Cosine 2 pi plus e to the sine pi. Okay. Well, this is 1,
I'm pretty sure they can.
and then this is 0. So then this whole thing is 1. So 1 plus 1 is 2. Oh, negative e. Okay, so I know that this is negative e from part A. And then I need to find the tangent slope of h at 2, but I have this graph. So at 2, here's the slope. It's negative 1 over 3. So e over 3. Okay, let's see. M is this function. Oh boy. So g of minus 2x times h. And then I need to find m of 2. Okay.
Oh man. Last night it was my shell arsenal, so hot Ivan. But then you
Okay, I need to take the derivative of this. So do some product rule and chain rule. So the derivative of this part is all of this. And then you multiply by h. Then you take g, multiply by the derivative of h, which is h prime. And then I want to find m of 2, m prime of 2. So I just plug in 2 into all of these places.
no. My girlfriends, we use the messenger. Facebook,
Okay, and then all of this is either in the charts or the tables. Well, the tables and the graphs. Okay, so let's do h's stuff first. So h of 2,
but it's only like once every like 3 months or some shit. It's not often.
h of 2 is right here. Do they expect me to do a decimal value?
We all canceled our tickets to Japan because that's not happening in a month.
And then also, I need h prime at 2, which I found earlier, I think. Right here. That's negative 1/3.
No, have you? Would you want to? I feel like it's such an old people thing.
Okay, let's see if I'll do g, and then I'll deal with h of 2 later. G at negative 4 should be on this table.
Yeah.
It's 5.
I want to.
And then g prime at negative 4 is negative 1.
Yeah, right.
So this is 5.
I don't know. No, I'm not crazy. But no.
And then g prime at negative 4 is negative 1. And then saving this for last just because it's a little annoying. To find out the h value at 2, I essentially need to make a linear equation, and it's a straightforward linear equation. That's just y equals negative 1/3 x. So then at the x value 2, it's negative 2/3. And then we go from here.
Those like mini boats that go around like Castle Island and shit. Have dinner, and then one year the water was really choppy, and it was really raining a lot.
So I think you get this.
Started leaking. Yeah, that.
And then let's see.
We were like draining the roof.
Last question.
And
And then, wow. I'm like 20 minutes early if I wanted to stream for 2 hours.
And like I brought gravel.
Is there a number c
I only had like 4 or 5
in this interval
like split it up.
such that g of c is negative 4? Okay, this screams mean value theorem.
Gravel. So funny.
But let's just double check.
Like I was just sitting there.
Yeah,
and I was
g is differentiable,
like, fuck this. And I
so I can apply mean value theorem to it from negative 5 to negative 3. So just looking at these values here, is there going to be something that has negative 4?
It was fun, but like
Okay.
I don't like singing the Christmas carol well.
Okay, let's try this out. If I take g of negative 3, I'm going to start with
And I was like,
these two.
and then in the later years they stopped making us sing. They're like, fuck.
Anita,
They would be like,
question, but it comes with a figure, and you don't know how to send it.
want participation.
Um,
Oh, the table who sings the most will get
If you have a
prize.
Twitter,
The loudest,
then
right?
I think there's a link to my Twitter below. So then you can send me a pic through Twitter. Unfortunately, I don't have a Discord yet. So you can't join the Discord and send me there. So I think, yeah, the best bet is make a Twitter if you don't already have one, and then tweet at me the picture. Don't have a Twitter? Then I guess you gotta make one. Or if you upload, you can like upload the picture to like Imgur. Can I Messenger send it? That implies that you have me on Messenger. So if you do, then sure. I have no idea who you are.
I don't know why I always get the fuckiest like visitors. It's so shitty because like, you're outside the tent.
I'm sure I do know you,
and then
but
you, like, open the tent and go inside, and then it like goes to black, and then like, ooh, this is fun, and then it like opens up again, and there's like some fuck with you around, and you're just like, fuck.
But here, I'm gonna take the secant line
Yeah. Fuck that shit.
of the boundaries of this interval they told me. And we're just gonna see what happens.
A lot of it is cuteness and personality.
So 2 minus 10 And then over here is 2. This is -8 over 2, which is -4. Aha! So, there you go. We have a secant slope of -4, and then because g is differentiable on that interval, then by mean value theorem, that means that there is some c value in between -5 and 3 that has the tangent slope of -4. And then we're done. Okay, so let me see if I got this picture. Okay, let's see.
I don't like penguins.
So, Anita Yellow's figure is
She sounds snooty.
some sort of staircase figure. Anyways, okay, so here's the figure, and it just goes up by 1 each time. So it says here, if there are a very large number of steps with a very small width, and the very small height increments, what would be the approximate area of the region shaded? And then this goes to 10, right?
No.
Well, so just imagine that like you had thinner and thinner rectangles. Then eventually it just makes like a all of the rectangles they basically just make this straight line. So you want to find essentially the area of a rectangle that has a base of 10 and a height of 10. So that should be easy to do. So hopefully you can see why that happens, right? Like they're making the rectangles thinner so you can fit more of them in. But because you know that it stops at 10, like look, if you look at your diagram, the highest it goes is 10. Because each bar goes to the x value. So like the right x value of the bar. Like this bar has a right x value of 4, and then it goes up to a height of 4. So the last bar should have a height of 10. And then as you get thinner and thinner and thinner, it looks less like a staircase and more like a straight diagonal line. But it still stops at 10. And it still goes from 0 to 10.
John Cena?
Okay. I guess I'm done. So let me check my answers. And then I guess I'll call it an early stream. So here's the answer key. And it says 176.3.
Wow. So my student.
No, I don't really. Can't you do it?
So my student earlier sent me like an Instagram profile on Instagram and linked me to it. So I was like, oh, that's weird. Why would you do that? And then
I'm giving you content? Yeah, but I don't want your content.
it's like someone like,
Your content is like
do it now.
hard.
And I was like, what
And then
the
you're
fuck
also
is
now
that?
telling me it's tedious?
Oh fuck, that's supposed to be for a friend.
Okay, I have a slightly off answer, so
He's like, it's supposed to be for a friend.
you think that I would... I am also very lazy. And you're coming from a position of stronger math capability, so you can figure it out yourself. Okay, let me see where went wrong. 2 times 50, 2 times 50, 3 times 14, 3 times 14, 5
Literally a
times 6.5.
thought
Oh, I have 6.3, but that shouldn't have changed things too much. Okay, this is slightly off, but the method is right.
Well, Emily was working for NAS.
Okay, part B. We have an overestimate. It says overestimate. That's good.
And then Danny is working for London Drugs. And he's
101.33. 101.33.
he wasn't in pharmacy school. He's in radiology now at BC
And
FR.
then,
He was never in pharmacy school.
wait, where's my answer for this?
And you know, my other ones were like got into nursing and shit. Virtually all her jobs now. Like all my old
Oh, oops, I forgot to do this question. Oh well. Okay, let's see. 20 pounds, 20 pounds,
What?
minus 8. You can see the minus 8 right there.
They fucking like dive into the fucking like fake news conspiracy theory shit.
Decreasing, you can see I said decreasing.
What else do you think they're fucking doing at home? Not doing anything, right?
And then 23.3.
So embarrassing. Just consuming all of this like fake media. Misleading
And then I have
media.
41, so I went wrong somewhere. So let's see where I went wrong. Oh shoot, I forgot. G is the amount of bananas that get restocked, and they don't start at 0, they start at 3. I think they told you that earlier. Yeah, after 3 hours. So this is wrong. That sucks.
I ventured into my family group chat for the longest time. After the longest time.
Okay, let's see.
My grandma has this huge bruise on her forehead from when she fell. Like,
F of 6 is 3, but I got 4. So I guess I messed up somewhere too. Oh wait, no, I have it right here, 3. Okay, never mind. It's good. And then f of 5 is 10 minus 2 pi. 10 minus 2 pi. Let's see. Intervals. Negative 6 to 2, 2 to 5. 2 to 5. Less than 2. Oh, right. This has a lower. So that should have been negative 6 over there. Okay, my minimum absolute is f at 2. So that works out. Negative 1/2, negative 1/2. Doesn't exist, doesn't exist. Okay, let's see. 91 minus 16t. I have that right here. And then 43 Celsius, 43 Celsius. Let's see, concave up, so it's an underestimate. I have concave down, so something went wrong here.
Does he what?
Oh well, something went wrong here.
That doesn't play out loud when he streams. It's just on the headphones, yeah. I know, we high tech.
And then internal temperature 54. I have 54, so that's good.
So our boss said
Okay.
we need more than 100,000 for down payment for the pharmacy.
Moving left between 0 and 1. That's what I have here.
Whenever I have the money.
Oh, they do the same diagram as me. Nice.
Well, I have to.
They move in the same direction 1 to 3 and 5 to 8. That's what I got right here.
No, I'm gonna buy a townhouse. Like, what the fuck?
Speed is decreasing. I have decreasing.
Because she was like, oh, so if you're gonna buy a townhouse,
I have 23. Or they have 23. I have negative 27. So
like a couple years.
something went wrong again.
I don't know.
Oh shoot.
Well, I told her, I was like, well, my dad.
This is just the change in direction. And you need to know its initial. You need to add this to the initial position of Q. And that was here.
And she's so bitter and like resentful that she would rather like let it go to public auction for less money than to sell it privately.
Wait, so then I add 5 here.
Like clinging on. She's like clinging
But that still doesn't get me
until, like the last possible second. She's insufferable.
23.
She's fucking over everybody, including herself.
Okay, I just evaluated my integral wrong somewhere. Because I have exactly what they have after I added the 5. I thought I was doing so well this paper. But lots of small mistakes here and there.
Yeah.
Okay, let's see. F of pi is negative 1.
Yeah.
I have negative e. Oh,
Yeah, that's
sine of pi is 0. So this should be negative 1. Which means that this
I need to go look in the fridge. What am I gonna eat? No, I'm gonna be on the stream.
is negative 1, negative 1. So this is just 1 over 3. Yeah, 1 over 3. Yeesh, this is not looking good. Okay. They have negative 3. And I do not have that. I have negative 8 over 3.
I know, I don't know what I'm gonna see again.
Oh, my numbers are exactly the same. So I somehow messed up my math. Oh yeah, I definitely messed up my math. 4 and 5 make 9, not 8. And then negative 9 divided by 3 is negative 3. And this one was just MVT, which is easy to show. We did that. So overall, pretty, not great, but not bad. But with that being said, you know, I'm slightly just under the 2-hour mark, so that's a pretty good streaming time. Lately they've been going closer to 3, which I guess is good, but at the same time not so good, because that means I stay up later and I have work the next day. But yeah, for those that are here today, slow day, thanks for watching, and yeah, I guess I'll come back on Thursday, so I'll see you guys later.